Hi everyone. Today we're going to go over lesson 37 practice set. So let's get started. This lesson deals with finding the area of triangles and rectangles or compound shapes. In this specific instance, compound hexagons, which are really just hexagons made from two or more rectangles. But we'll start with triangles first. So find the area of each triangle. Dimensions are in centimeters, so our units are, since we're dealing with area, we're going to have square centimeters or centimeters squared. Now, to find the area of any given triangle, we use a formula. And the formula is you take the base, you multiply by the height, and then you divide that product by 2. Alternatively, you can multiply the base by the height and then just take half of that. Now, you'll notice that this is actually very similar to the formula for area of a rectangle, which is just base times height. And that's because every triangle, you can work it in a specific way so that it actually becomes a rectangle. But a triangle would just be half of that rectangle. So the area of the rectangle is base times height. The area of the triangle is half of that because it's half the rectangle. Now, this specifically works when we have right triangles. The given height, for non-right triangles is the point from the top vertex to the base, and that's going to be a perpendicular point. And you could actually, like I said earlier, work these around. You'd have to cut some things here and there so that they become rectangles. For example, here we formed a perpendicular line, and then you could actually make it a rectangle over here, which would be base times the height. But since you did half, since you basically cut the base in half, that's where the half comes from, is cutting that base in half. So let's go ahead and get started with A. Our base here is 12. First, you have to identify your dimensions. Our base is 12. Our height is 5. So now that we have our dimensions, we just use the formula. So it's going to be 12 times 5. And once we have that, we're just going to go ahead and take half of that or divide that product by 2. We are going to take the base times the height first. The only instances where we wouldn't, really the order here doesn't matter. If you wanted to take half of 12 and then times 5, that would be fine. Typically, though, you want to keep that base times height being multiplied first just because it makes it easier to take half of that at the end. You take half of 1, you open up yourself to a mental mistake where you took half of 1, you multiplied it, you forgot that you took the half, so you take half again. And really you're finding a quarter of the area as opposed to, well, a quarter of the area of the rectangle, which is half the area of the triangle, which is still not correct. So the order here doesn't matter. You could take half of the height times the base, half of the base times the height, base times height divided by 2, base times height, take half of that. But personally, I prefer to multiply base times height and then divide by 2. So go ahead and solve that on your own. For B, the thing is that we have to remember is that the height is the distance from the top vertex. So we identify the top vertex, which is here. It has to be perpendicular, which means it has to form a 90-degree angle with the base. The height has to be perpendicular to the base. So that means that not just any side of a triangle can be the height. These equivalent sides, while they are part of the triangle, they're not the height because they're not perpendicular to the base. Any height of a triangle has to be perpendicular to the base. Otherwise, it's not going to work as the height. So the height is not 10, it's actually 8 because that's what's perpendicular to our base of 12. So we then use the formula. We take the base, multiply by the height, and then you just want to take half of your product there. Now, while the base is 12 and it's not never going to be 8, the base has to be 12 and the height has to be 8. One thing that I want to point out is that you could do height times base. Because of the commutative property, the order technically doesn't matter. We just do base times height, I'm assuming, because it's alphabetical. But otherwise, the order of the multiplication doesn't matter. What matters is that you multiply correctly, and you keep in mind that once you multiply, you have to take half of it. Or if you're going to take half of one of the units or dimensions, then you just multiply by the other one. So for C, we have you'll notice the top vertex is here, and here's our perpendicular line. And we're given that it's a height of 6. But then the base does not include this little extended out portion because that's not technically part of the triangle. The base is just the side that the triangle is sitting on, which in this instance happens to be 6. So our area is 6 multiplied by 6, and then we have to find half of that, or divide it by 2. Keep in mind that your dimensions are in centimeters, and since we're looking for the area, that means that all of our answers are going to be in the unit of centimeters squared or squared centimeters, if that's more your flavor. Either one of those units is correct. All right. For D, we want to copy the figure in example 4, find its area by dividing the shape into 2 rectangles and adding the areas. So for letter D, we're going to scroll down here. And we want to split this up into 2 rectangles, right? It doesn't really matter how you choose to make it into 2 rectangles, but I'm going to go ahead and do it this way. And then we'll do it the other way just to kind of show you that it really doesn't matter as long as you calculate everything correctly. All right. So now the temptation is going to be that this rectangle is 14 times 10, but that's not actually accurate because what ends up happening is that you actually split this side into 2 sections. Now, whether they're equal or not, we don't really know. But what we do know is that this section matched up with this section makes it 5 units long because on opposite sides of the rectangle, the sides are equivalent. And you'll notice then that if the entire thing is 10 and this part is 5, then the other part has to be 10 minus 5, which is also just 5, right? So now we have that this portion of the rectangle is 14 times 5. We're not looking for perimeter, so it actually doesn't really matter if we find the lengths of these sides. For now. If we're looking for perimeter, we have to know those sides. But in this instance, we can work with what we have. So now, to find the other rectangle, we take the base, which is given to us that it's 20, and we take the width, or the length. Sorry, the length is 20 and the width is 5. In rectangles, we use length and width. Triangles, we use base and height. Functionally similar, but they do tell us different things. All right. So now we find the area of each. So 14 times 5 is 70. And 20 times 5 is 100. So finding the sum of these gives us 170 units squared. Now, I did mention that it doesn't really matter how you decide to split these up. And let's go over what that looks like once I bring back my rectangle. So let's split it up a different way. Look, it's back. Yay, magic. All right. So we're gonna draw our line. We're gonna draw our line. And so now we have this big ring. So now this one is 14 by 10. Okay. We are given that. We see that, the entire structure would be this. And the 14 came from the length at the top, and the 10th came from the width on the left. So now we look at this little one. So we know that part of it is 5. All right, that's given. But now we need to find the length, which we are not given. So this is a little bit trickier. But you notice that we are given in the larger compound hexagon, the entirety here is 20. But we know that just this portion right here, because it is split into 2 parts by this section right here, we know that the opposite side is going to be 14. Which means that both of these combined have to be 20. So how do we find our missing length? Well, we can replace it with the variable and then just make an equation. X plus 14 equals 20. We're going to use our inverse operation here. Which means we're going to solve by using the opposite operation. These will cancel out. And our side length is 6 units. Which means we're going to multiply 6 and 5. 14 times 10 is 140. 6 times 5 is 30. And would you look at that? When we add them, we get the same area. So as long as you split them up into rectangles, how you split them up into rectangles isn't really as important as, making sure that you find the appropriate side lengths for each of your new rectangles to add them up. So we move up to E. A 4 by 4 inch square given to us here was cut from a 10 by 12 sheet of construction paper. What is the area of the hexagon that's left? So the way we can do this is to find the area of the hexagon by subtracting the area of the square that we cut out from the area of the original triangle. So what we have here is the area of the square, which is a 4 by 4 square, giving us an area of 16 inches squared. And then we find the area of the original rectangle, which is a 12 by 10, which using mental math, 12 times 10 is 120 inches squared. So to find the area, we just simply subtract the two. And since it is still area, you're still going to have inches squared as your units. So keep that in mind when you subtract them. And I'll let you subtract those on your own. For F, we want to find the area of this figure at the right. Dimensions are in inches. So since we're dealing with area, our answer is going to be in inches squared or squared inches. I'll go squared inches this time. All angles are right angles, which means we can split it up into rectangles. So again, how you decide to do this doesn't really matter. You could do it this way, or you could do it this way. Either way, you'll end up with something similar. I am going to do it this way because I see 20 and 8, which is a very easy mental math calculation for that portion of it. 20 times 8, we can put it there. If we extend this line out, we see that this side is 8. So this and this portion combined make 24. So then how do we solve for x? We subtract the add end from both sides. Cancels out. 24 minus 8 is 16. So that doesn't finish the problem because now we have 16 being multiplied by 6. So we have 20 times 8, which is 160. And then we have 16 times 6, which is, so, I'll do the box method here. I split up 10 and 6, 16 to 10 and 6. Multiply that by 6. So 10 times 6 is 60. 6 times 6 is 36. And then I add those up, giving us 96. And now you can find the sum of both rectangles here. For G, how did you find your answer to F? Well, it's pretty simple. You split it up into 2 rectangles, and then find the area of each, and then you add them up. That's all we did. Nothing too crazy. For H, we want to write 2 formulas for finding the area of a rectangle. We went over the 2 formulas earlier. You could do base times height divided by 2, or you could do base times height multiplied by half. There's all kinds of other ones that you could have done as well. You could take half of the base and then times the height. Likewise, you could do half of the height times the base. Any of those will work. However, typically we stick to these two because it allows us to calculate, and then we just take half of our calculation, which is always, I feel like it's always pretty simple. And this way you don't run the risk of forgetting if you already took half of it or not. So that's how we find the area of triangles and compound figures from rectangles. Let me know if you have any questions in Google Classroom or in the comments. Hope you have a great day, and we will see you later.